We're going to spend a bit of time now discussing how we get from point A, having a problem that we're trying to solve through quantitative means, to point Z, having an outcome, a result that is actionable and that we can send back to the client. There is, in theory, a step-by-step guide to running data analysis projects, and while it follows, roughly speaking, the steps of the scientific method, so we're going to call this the analytical method. There's no such thing out in the world, so if you go on Wikipedia, for instance, you're not going to find these steps, but I think it's an understood series of steps which are meant to mimic the scientific method, as I've just said. So you're going to start by clearly stating the objective or the reason why you're about to embark on data analysis. This sounds like a bit of a silly step to have, but it's actually very important, especially if it turns out that the data analysis results don't match the expectations of the client and or the analysts. And then you'll have to take some time to set up the infrastructure for data management. Because in the next step, you're going to be collecting data. That data has to reside somewhere. Once you've collected the data, you'll have to prepare it for analysis. That usually involves cleaning the data, formatting the data. What is typically called data wrangling would come into that, transforming it. Once it's prepared, you move on to the next step, which is to say you'll want to spend a bit of time exploring the data. Very often this is done at a step 0, using the data that has been collected in a previous analysis, or at least it has started being done in step 0. But once you've collected your data, you'll want to spend some time exploring it. Once you're done with the exploration, you'll spend a fair amount of your time on the modeling and analysis, answering the question that you're asking in step 1, and then eventually you'll take these results and use them in the right environment, or to provide the type of decision support that the stakeholders wanted. And eventually you'll communicate either the results of the analysis or the decision support or the strategies or the steps or the policies that have been implemented using the results of the analysis, and you'll document results. Now, the data analysis part itself is just a single segment of the flow, right? In order to be able to get to the point where we do analysis right here, we need to do a fair amount of work prior to it, and we'll actually have to do some work after it as well. Sometimes the order is not respected. Sometimes you have to do certain things first, like as I've mentioned, very often you'll do data exploration on a prior version of the data set. That's going to end up influencing or informing what your objective should be, and it may be a bit of a mess, but on the whole, it does what it's supposed to do, assuming that you conduct each of the steps correctly. You might see something that looks a little bit like this. Now, I don't know if any of you have ever worked with real data or data in the real world. I have to tell you that this isn't at all how the data analysis workflow actually goes. In reality, what's more likely to happen is that you'll start by stating your objective and your rationale. Then you'll try to set up the infrastructure and data management, and then you'll realize there's a bunch of hurdles. You might not have the funds to purchase the right kind of infrastructure, or the current IT personnel is putting up roadblocks. They don't want you to get data in that format, and so there might be a lot of back and forth that could lead you to revise your objective and your rationale. Eventually you'll be happy with both the objective and the infrastructure and data management options, and then you'll move on to the data collection stage. And you start collecting data, and you might realize that, hey, hang on, my data collection process isn't quite appropriate, or I'm not collecting what I think I'm supposed to be collecting, so I might need to go back and change my objective and my rationale, or conceivably, the data that I'm collecting, I'm not equipped to store it. I'm collecting too much of it, or it doesn't have the right kind of format. I might need to go back and revisit my infrastructure and data management module. If you do this properly, you'll be happy with your objective, with your infrastructure and data management, and with the data collection. So then you can start preparing the data. As you're cleaning it, you might realize that, I'm spending an awful lot of time cleaning this data. Am I collecting it the way I'm supposed to be collecting it? So the data preparation, the cleaning, the formatting, the wrangling might lead you to realize you haven't been collecting the data properly, and then you might have to go back to square one. You might realize that your objective and your rationale weren't sensical. And again, the infrastructure and data management might be affected by the findings in data preparation. You might find that they weren't up to the task. Hopefully, at some point, you'll be happy with your objective, with the infrastructure and data management, with data collection and with data preparation, and then you'll start doing data exploration. But what's probably happened is you started exploring the data as you were collecting it as well. You didn't wait until it was prepared to explore it. You probably started exploring it. Perhaps you hired a student, co-op student, to start working on this data exploration. And that data exploration, as it's happening, might make you realize that there's issues with data preparation and back to data collection and so forth. And you see what's happening here at every step of the way. You need to be willing, able, ready to revisit the assumptions that you had made at every one of the preceding steps. Just about the only time when you can't go back to square one is once you've communicated the results to the general public. By that, what I mean is, you've communicated the results. You might have made mistakes. And if you've made a mistake, it's sort of important internally to go back to square one and fix it, and then to let people know you've made the mistake. But once you have communicated the results to your stakeholders, to your shareholders, to the House of Commons, to you name it, it's a little bit difficult to go back to square one. So you, as a quantitative consultant, hopefully will be involved these steps. We're rarely involved with these steps, although sometimes that happens. But you need to be ready to revisit each of these at any moment in the process. Because once you've handed off your work, stakeholders, you've lost the ability to affect change in the pipeline. I have to tell you that in practice, it is never the case that you'll be able to go in a straight line from step 1 to step 8. It is typically what some people on Reddit or the internet would call a cluster effort. Okay? It's a huge, hot mess. And if you're the type of person who needs to have all of their books shelved properly, obviously not a problem with me here. If you're the kind of person who can only move on to the next step once everything has been fixed, you're going to find doing quantitative consulting will be very taxing for your emotional well-being. That is not how quantitative projects are run, even when you use project management techniques, which we'll talk about a bit later. Another thing to keep in mind when you do quantitative consulting, it is usually going to be the case that you need to run a large number of models before you can make a final selection or a final prediction. And the process is iterative. very often you'll need to go to the domain experts, which is to say the clients, to ask for clarifications, to ask for help in deciding what's crucial, not crucial. And they might be wondering why you keep on coming back to them to ask for advice, because they've hired you to be the experts. Why are you consistently coming to us and pestering us with questions? It's important for the clients to understand that they are not at arm's length in the process. They have to be partners in your attempt to solve their problems. Another thing for you to keep in mind, if you do not use domain-specific knowledge, if you basically jump in without really knowing the context of the problem is, the context of the data is, on average, you will not be able to beat random models. I've gotten this slide from a course that Joe Blitzstein and Hans-Peter Feister teach. I think it's at Stanford, perhaps Berkeley, I don't remember. At any rate, you can follow the link to try to get it. But this sort of gives you an idea of how we will approach our problem, our project, and how we should approach projects in general. Right? You ask the question, you get the data, you explore the data, you model the data, you communicate, and you visualize the results. And there's a number of relevant questions that are being asked or shown for you here, and you clearly see here the back and forth. So I'm not the only person who thinks that this is a hot mess and that there's a lot of back and forth. It seems to be a law of consulting nature. Okay? You need to expect something like this in any of the projects that you will work on. And if this doesn't happen, either the project was beneath you, in a sense, it's way too simple, it's like an assignment problem, or you're not asking the right questions and you're missing some very important things. Okay? You should be finding that you go back and forth a lot. In practice, people have tried for years to really inform quantitative consultants and clients of the nature of quantitative problem solving. And so about 25 years ago, somebody released the cross-industry standard process for data mining. Data mining is one of the ways in which you can do quantitative type things with data. I'm not going to go into full detail. You see a slightly different approach to this. There's a few important features here. The fact that there's meant to be some back and forth. You're seeing it here, you're seeing it here, you're seeing it here. You also get to see this circle with the arrow, which means that, in a sense, a good project, once it leads to deployment, should lead to more questions, or more projects, or more problems. When you go through the slide deck on your own, you'll see a number of items for each of these boxes. We're going to skip them in this video, however, but I invite you to take a look at them on the slide deck. I think the value of showing you this crisp DM diagram is to really show you what typically happens in practice. In practice, businesses have data. They've collected data. And they go through the process of understanding it. And as they understand it, they prepare it. And as they prepare it, they model it. And their modeling might allow them, or their modeling might get them to understand that they need to prepare it in a different fashion. But that's fine. They go back to modeling it. Then they send their models to be evaluated. And then they'll go back to data understanding, because that's what they have. There's a number of issues here. People don't spend the time stating their business objectives, what they're trying to do. So there's a lack of clarity in many applications in the real world. Once they get to evaluation, well, you just blindly hand off the project to IT or communications and you wash your hands from it, or you're being told, no, this is not your job anymore. We're going to send this to IT instead. There might be a fair amount of mindless rework here. Now, I've told you before that you'll do a lot of back and forth. That's true, but the back and forth isn't mindless. You're not going back and forth just for the sake of going back and forth. You're going back and forth because as you understand the data more, and this is achieved by cleaning it and exploring it more, you realize that there's a certain number of things that you hadn't fully taken into account at various previous stages. This is not back and forth for the sake of back and forth. It's not mindless back and forth. And a very interesting feature of what seems to happen in practice, even though there's a lot of mindless rework, what we typically see is a failure to iterate, to go from the deployment to new business objectives. Projects are often one and done. Now, it's important for you as quantitative consultants to understand that the process is iterative. You need to go back and forth in a non-mindless fashion. And non-linear, you might skip over some bits and come back. But you also need the stakeholders, which is to say the client. And very often it's not the manager of the project that needs to know this, but their higher-ups. They need to keep in mind that the process is iterative and non-linear. It isn't something as simple as, I need something by 3 p.m., make it happen. In order to get to that 3 p.m. point, you might actually have to spend 3 weeks working on the data and the process with the client. If the client doesn't understand this, if the client thinks that you go from point A to point Z or B in a straight line, you are in for a world of hurt. They will think you're ineffective. They're not going to rehire you again. They might not even want to pay you to do the work you're supposed to do. They might think that you've lied about your qualifications. Okay? So you have a responsibility to make sure, and this is often done through the proposal and through regular progress meetings, progress reports. You have a responsibility to make sure that the stakeholders understand the nature of quantitative work. If you're lucky, they have a quantitative background and they already understand that. But if they had a quantitative background, they would probably be in a position to hire quantitative people or do the work themselves. They wouldn't need necessarily to go and get outside help. Okay? You have to be on the lookout for this. This is one of your responsibilities as a quantitative consultant. There's a number of issues associated with data collection and storage because you're going to be working with data at some points, right? So the data flows and it's being collected. There's some possibilities there. Some of the data might be collected in only one pass. You have a static data set, the iris data set, the poisonous mushroom data set. Data might be collected in batches, which is to say every week, every Sunday at midnight, we do a data dump. So data changes regular interval. It's updated. But the data might be collected continuously as well. So depending on how the data is being collected, you need to find ways to store them. And your ability to store them and how you decide to process them will reflect how they've been collected. But it's also going to have to reflect how much data there is. When I started out as an undergrad in mathematics and statistics, email didn't even exist, right? We used to pass data around on these little floppy disks about big, the thing that's used as a save icon. Microsoft products, there was not a lot of data. Partly because we couldn't really store much data. You also need to take into account how you're going to want to access the data. Like if it's in a database, not a flat file, not a table, a database, well, the analysts or the clients, people are going to need to access the database, to query the database, and to output something which will eventually be fed once it's cleaned properly into algorithms and models, how fast must you access the data? How often must you access it? Who is allowed to access the data? And same goes with the processing. One of the issues there as well, if you're collecting data continuously, say over like years and years and years, some of that data may go stale. Like data might have a best before date. If you understand the context in which the data is collected, if you understand, or if you have some domain knowledge, you might be able to mitigate or recognize when data has gone stale and shouldn't be used in models anymore. But if you're just blindly analyzing data, that might be a hard thing for you to figure out. Now, the data models, the metrics, the measurements may need to be updated as new data is collected, right? Perhaps you update it, well, you just do it once with your static data and there's no need to update anything. But if you have batch data coming in, presumably you'll want to rerun the models with this new data that's coming in, and potentially by removing some of the stale data. So it seems pretty straightforward, but then you need to ask yourself questions like, do you rerun the entire model on the full data set, which has been updated, or do you just change the model a little bit by running it on the new batch data coming in and finding some way to stitch the new model with the old model? Right, this is called data streaming, or data analysis for streams. So why not just redo it from scratch? Well, it could be that your original model took into account 1 terabyte of data. Your new batch of data coming in is going to add 1 megabyte of data. Do you really want to spend all the time to rerun the data for an additional 0.1% of the data? It might be that you need to come up with smart ways to update your models and your measurements. And the same thing happens if data is coming in continuously. Another thing you'll have to get used to is seeing this quote. Every consultant worth their salt need to know that every model they will ever produce is wrong. There are no models that are right. All models are approximations, right? What you hope is that some of the models that you're going to be building will be useful nevertheless. They will provide useful lies. One of the ways in which you'll be faced with the wrongness of your models is through assessment and validity. Right? This is part of the process. You need to verify if the work that you've done makes sense in the context of what you're trying to do. Well, your models should be current, but they also need to be useful and valid. It's not enough to be current. If you have a useless model that's current, you might as well not have a model. And if the model is invalid, well, why even keep it around, right? How do you find out that the model went from being current, useful, and valid to not current anymore, not useful anymore, not valid anymore? You need to test it. You need to test its results on a regular basis. You need to have the assessment be part of the workflow for the project. Like if you watch things on Netflix, films or TV shows or what have you, how long does it take to figure out that you no longer like action movies and you'd like to watch something else? I made a mistake once. I went through a bunch of comic specials, stand-up comic specials. I gave them thumbs up. And now I am getting flooded with stand-up comic specials. Netflix seems to think that the only thing I care about is stand-up comedy. Well, the same question goes for usefulness. How do you react to a conceptual shift? How do you change your position on issues? Presumably you're not the same person you were 5 years ago, 10 years ago. How do you react to this new evidence that makes you change the way you view the world? How can you make that happen for your models as well? One of the issues you may have as a quantitative consultant, and that may seem paradoxical, is that you might have been successful in the past. Your models might have been very good in the past. They might have done the job for which they were designed, commissioned. Well, if you've been successful, you might be reluctant to reassess or reevaluate the model. And if you don't actually reassess or reevaluate the model, you might miss the fact that there's been a conceptual shift, a trend shift, something is different. If you want to use the model, the results of the model into a report or for stakeholders to make decisions, you need to confirm first that the model is still valid, is reaching valid conclusions about the system of interest. You need to verify that the system of interest hasn't changed and that the data that is being fed into it still has the same properties as the data that was used to train the model, if you're using a data science model. Something else that's part of the workflow that you may need to get used to once you have handed off either the analysis of the model to the client. Well, it will take a life of its own. If you're lucky, they will be using the work that you've done. But you're not part of the process anymore. You're not an employee of the company. And you may not be able to control every aspect of dissemination. Your results could be misappropriated, they could be misunderstood, they could be shelved, they could be misrepresented. Is there anything you can do to prevent this? Potentially you can include a clause in your agreement with the client that you'd like to be consulted before anything goes out to the general public. But usually, once you've done your work, and you've documented it, and you should document it here to avoid some of these issues, you're not part of the process anymore. Quantitative consulting, in some sense, never ends. That could be exhausting, but it's also very rewarding because every time you go through an iteration, or if you work with the same company on multiple projects, you can be part of something that gets built over a long time period. And it's really neat to see the project go from a little seed to a gigantic flower.